Hello, everyone. Again, welcome to the first webinar in the Mining Operations, the Issues That Matter Now series. My name is Sema Kerr, and I'm the General Manager of Marketing and Events here at Austmine, and I'll be your host today. Before we begin, on behalf of Austmine and our presenting companies, I'd like to acknowledge that I'm hosting this webinar from the lands of the Whadjuk Noongar people. I acknowledge the traditional custodians of the various lands in which we all meet today and pay my respects to elders past and present. We also extend that respect to any Aboriginal and Torres Strait Islander people joining us today. This webinar is part of the Austmine's Mining Operations That Matter Now series. Each session focuses on a real operational challenge that the mine sites are dealing with today, whether that's improving productivity, reducing costs, or lifting performance. We brought together a range of Austmine member companies to share practical examples of how they're helping mining operations tackle these challenges, with the aim of giving you useful insights and ideas that you can take back to your own workplace. To give you an idea of how today's session will run, we'll hear from each of our presenters before opening up for live Q&A. If you have a question at any time during the presentations, please type it into the Q&A box at the bottom of your screen. If your question is for a specific presenter, please include their name in your question. The webinar is being recorded and will be made available to all registered attendees on demand after today's session has ended. I'll just move on to the next slide, please, Renee. Thank you. So joining us today are representatives from 4 of our Austmine member companies who will be sharing their expertise, practical insights, and real-world examples from across the mining industry. Joining me today, we have Courtney Bailey from Voconics, Matt James from Pointera, Bradley Price from NLT Digital, and Ram Rangsamy from MST Global. So to get us underway, I would like to welcome our first presenter, Courtney Bailey, Agriculture Sector Lead from Voconics. Over to you, Courtney.
Thanks so much, and great to be here today. So what we're doing today with my presentation is actually looking at some work we've conducted within an entirely different context and talking about what that could mean for the mining sector. So what we're looking at is a data-driven approach to attracting and retaining workforce and putting some real physical measures behind that based on some evidence from work we've conducted in the agriculture sector. I'm here today on behalf of Voconic. We're an engagement science company, and we help organisations listen more effectively to the communities that they work alongside. So on to the next slide, let's have a look at what it is that we were doing in this research methodology. So we undertook a piece of work with AgriFutures Australia to really understand what's happening in terms of both attraction, so bringing people into the Australian workforce, and retention, so keeping them there. So to do this, we conducted 2 different types of methodology, one on people that were currently engaged in the workforce and one on people that were community members wrapped around those particular industries of choice. We created a research methodology based on desktop review, industry consultation, and a series of long-form interviews to better understand what it was that those core issues we were trying to look at. We also then dug deeper into specific regions of interest, and that I think will help us when we look at it from a mining perspective, because those regions had very similar issues in terms of attracting people to regional towns, bring them in and actually keeping them there, specifically in regards to what was happening in the place of those areas of interest. So we conducted quite a robust study, over 3,000 across the sample for the community members and over 1,500 for rural industry workforce, to really understand and model what was happening in both attraction and retention. And so moving on to the next slide, let's talk about what it was that we found. So as I mentioned earlier, we've got 2 key outcome measures as part of this research. So the first is retention. So that's, how likely are we to keep people in a particular industry? And the second is consideration, which we're coining attraction in this. Both metrics were scored on a scale of 1 to 5, with 1 being not at all, 5 being extremely. And both are seeking to understand at a deeper level, before people are leaving an industry, what are the diagnostics that might help us keep them in there, or also what's actually happening in the meta world of employment at the time. So in terms of our retention in the agriculture industry specifically, we scored a 4.1, which is incredibly good. Basically, that's what that's telling us is once people are in that industry, they're more willing to stay. They're not looking outside. Interestingly, though, this isn't a measure of motility between different roles within industry. This is just people staying in an industry. And I think some of those insights are really critical for us as a group to look at, to see how it is that we can make sure that our workers in mining are happy and engaged in their workforce moving forward. The second one is consideration. So how likely are you to consider a career in industry X? And that was significantly lower at 2.4. So when we're looking at that attraction piece, in particular in rural industries, it was primarily around the connection, and we'll go into some modelling on that in a minute. Now, that connection is multifaceted, but the majority of it was based on traditional relationships and connections with people in rural industries already. So interestingly, people weren't brought to those careers for money or through formal training. The most likely way people were brought into the industry was from informal connections and family connections with land and heritage. Critically, this is due to a number of different relational factors, which I've listed on the slide below, including the ability to listen and respond, working conditions, the contribution of an industry to the community and local community services, as well as things like mitigating and minimizing environmental impacts where possible, based on in a strict level of internal policies and procedures to hold people to account. And so on the next slide, we can actually see what it was that was driving both attraction and retention. And I think the key takeaway here for us is that they're actually two different problems. So when you're looking at a workforce from a meta level, Australian industry overall, you've got the piece around attracting workers. And for the Australian agricultural industry, as I mentioned before, that was quite driven by relational factors. Do you know somebody that works in the industry? Did you grow up rurally? And did you have some oversight over what was happening in that particular area? The retention model is much more complex, and I'll talk about that in a minute. Notably, though, there was a couple of very similar drivers between them, and those were the connection drivers. So if you look at number one, knowledge that leads to attraction on this path model or structural equation model here, that knowledge features in both models. And this isn't knowledge of the industry and what it does. This is actually knowledge of career pathways, opportunities, and ability to grow in both industries. And what we noticed across both the internal and external samples for this was knowledge of the mechanics of a career in both external community and internal workers was very, very low for an agricultural community. And so despite work that particular industry had been doing to make those career pathways and progressions really clear, it wasn't clear to either the community or the workers. And it was one of the number one reasons that both attraction methods and retention methods were falling down. So it's critically important that people know how to get somewhere and know how to progress in those pathways. The next things that were really related to attraction or heavily driving attraction were those connection pieces I talked about earlier. So those that had a really high connection to country and those that felt that rural industries were part of their personal heritage or story were more likely to come into those particular jobs. Very difficult to build that connection, and that's why our attraction levels were low, but also growing in agricultural rural industries. It's important for us to reflect on how we can increase that connection to mining sector, because there's much less of a generational farming, multi-heritage connection to land piece there. The final one, though, importantly, is procedural fairness. And so that's how much the external community felt that those particular workplaces were considering the needs of their workers and also listening to their community. So two factors that were loading there. And that's a really important one that we've seen across many of our models that are driven on relationships and trust as well. Moving over to what was driving retention. So we'll go back a slide still, sorry. We've got a couple of different factors here. So the first is actually health and safety. And I think this is a critically important one for your industries as well. So if we look at this particular driver, it was actually around whether or not the community saw that industry taking health and safety initiatives seriously. It wasn't around whether or not the workplace was safe and healthy in itself. So it was more around the checks and balances that industry was doing. And that was the number one driver of keeping people in their jobs, critically important. We also see that knowledge and connection piece, as well as whether or not people feel like they have a meaningful career, very related to whether or not they can see their career trajectory into the future. Finally, and surprisingly, the lowest driver of retention in this model was fair wage. And importantly, it wasn't this person feels like they're being paid the most money. It was actually whether or not they felt they were being paid fairly and appropriately for their work relative to other people in their workforce. So this sort of came surprisingly as a model that was less about money and what we can offer people and more about the utility and community that underpins these two different groups and how an industry can connect those people. And so that's where we see in the next slide when we talk about workplace versus place. So what we actually found undercurrent in this research is that actually satisfaction with various place-based infrastructure products mattered more than whether or not a community member was being paid or whether or not they had better employment opportunities. And so what we can see here is that the quality of schools, available housing and quality of housing, the percentage of people agreeing with whether or not those were appropriate is quite varied. And what we saw in the data set was motility for between industries was actually determined by whether or not a person could see themselves in a community supported by their industry rather than seeing themselves in a job. It's critically important. So finally, I just thought it was interesting in the next slide to see why people were actually leaving. And I think this is critical for us when we're thinking about workplace development. And so in the agriculture industry, most likely people to leave were the people that were under 35 in the first 3 years of their employment within the industry and predominantly males. So if we think about workforce as a movable stock, that is the most movable stock that we're seeing in these particular roles across Australia currently. And many of them have practical jobs such as primary producers or production processing. So a big overlap between the skill sets that we normally see coming into underground mining. And so I'll just leave you with the thought that effectively when we're looking at the workforce shortages here, it's actually less about doing an interview with someone at the end of their tenure and understanding why they exited, but actually looking at some of the intangible assets that are bringing them into a job and keeping them there. And how can we actually affect change on those levers? So I'll leave it there and welcome any questions at the end. Thank you.
Great. Thank you so much, Courtney. I would like to now introduce Matt James, Vice President of Business Development at Pointerra. Over to you.
Thanks, Selma. Good afternoon, and thank you for joining. As someone said, my name is Matt James, and I work for Pointerra. We're a Perth-based software company helping industries manage and analyse massive 3D spatial data sets. So our cloud-based native platform, Pointerra 3D, it delivers fast browser-based digital twins that integrate reality capture data. So this includes LiDAR, photogrammetry, video, IoT data, supporting operations globally. But today isn't about a pitch, product pitch. It's about it's a case study on 2 Australian underground mining operations, real scan data, and what happened when manual spatial analytics was replaced with an automated workflow. So that's the story I'm looking to discuss with you today. So let's start with the problem with both these operations shared. Underground mining has become routine. Underground mining scanning has become routine, but the processing side hasn't kept up with the pace. Each scan data set for these organisations took up to 4 to 6 hours to manually post-process with one specialist at a time. At an active operation running 50 or more scans per month, that's a backlog that only grows, and it grows faster than any single team can clear. Because the results sat with the survey department, operations, safety, and engineering teams were often waiting days or weeks for answers they needed immediately. So manual roadway dimensioning, convergence checks, and rock bolt QAs were slow, inconsistent, and prone to errors, simply because they depended on one person working through one data set, one measurement at a time. The core issue wasn't data capture, it was the gap between capture and action. And by the time insights arrived, conditions underground had already moved on. This gap is what the rest of the talk is about. So it's worth pausing at this point and because a lot of operations, that gap has become normal. Something people work around rather than something people expect to fix. To show that the gap closes in practice, we're looking at two real Australian operations. The first is a Tier 1 underground coal operation, where the priority was gate road profiles and route block QA across networks of more than 6,000 volts. The second is a hard rock gold operation, where the priority was convergence monitoring across arch roof roadways, capturing using SLAM and terrestrial laser scanning data. Different commodities, different geometries, different priorities, but the same underlying automated workflow running underneath both. Both are real operating mine sites, not tested environments or demonstration projects, which is part of why the numbers on the next few slides are worth taking seriously. Both sites ran the same 4-step process. First, classification: roof, ground, roof, walls, ribs, bolts, mesh, and services are separated automatically from the raw scan at 90 to 95% accuracy. So nobody is manually tracing services point by point. Secondly, sectional analysis. The system generates cross-sections at defined intervals and compares them to the design profile, catching convergence and deformation down to 25 to 50 millimeters, a finer tolerance than most manual measurements regimes can sustain across an entire network. Third, compliance checks. Roadway dimensions and rock bulk positions are checked automatically, with results heat mapped against installation specifications so a supervisor can see exactly where a heading falls outside tolerance. And fourth, everything publishes to a shared digital twin, browser-based, with no desktop software and no waiting on the survey team. A 2 million point data set builds and publishes in 19 minutes. None of these 4 steps needs a specialist sitting at a desktop for hours, which is really the whole point of automating the workflow in the first place. So what did this mean in practice for the coal operation? Manual processing had been running at 4 to 6 hours per data set. With the automated workflow, the same data set builds and publishes in 19 minutes. Roadway dimensioning time dropped 80 to 90%. Classification accuracy is held at 90 to 95% across the network. And the system worked at real scale, analyzing more than 600,000 bolts, which is not a pilot, that's a full network running in production. Just as importantly, gate road profiles now feed directly into Shearer automation systems, and over and under brake mapping runs automatically rather than being pieced together by hand. The operation estimates the annual value of this at $900,000 to $2 million per site, combining time savings, risk reduction, and fast decisions. That figure comes from the operation itself, not from us, and it's a useful sense check on what automated processing is actually worth underground once you take it past a trial and into everyday use. For a mine planning team, that is the difference between waiting on a weekly report and checking a dashboard before the morning meeting. The hard rock gold operation had a different priority: convergence. Manual processing there took around 2.5 hours per data set. The automated workflows brought that down to somewhere between 30 to 60 minutes, depending on the type of data set. Classification accuracy sat again at 90-95%, and deformation sensitivity held at 25 to 50 millimeters, which is a great deal. Which matters a great deal in arch roof roadways under active headings, where small movements can signal a much bigger problem developing. Instead of comparing scan to scan measurements by hand, the system generates cross-section automatically and flags movement before it became a problem, rather than someone having to notice it on its routine walkthrough. Like the coal operation, this site also estimated the same annual value of $900,000 to $2 million per site. 2 different commodities and geometries landing on a very similar number, which is a good indicator that these gains aren't coincidence of one site's condition. They're a property of the workflow itself. For a geotechnical engineer, that's the difference between reacting to a fall of ground and seeing it coming several scans in advance. Standing back, the value from both sites lands in 4 areas. First, design conformance. Roadway dimensioning dropped 80 to 90% because roadways are checked automatically against design profiles for regular and arch roof geometries. Second, structural integrity monitoring. Deformation sensitivity held at 25-50 millimeters at both sites, with convergence training flagging problems before they reach critical thresholds, not after. Third, asset management. More than 60,000 bolts were analysed and heat mapped against installation specifications, with a full audit trail stored across the life of each heading. So nothing depends on someone's memory of a site visit. And fourth, safety. Because of this analysis happening on the surface in a browser, fewer people need to go underground for routine checks. And the teams who remain responsible for that ground are acting on measured data rather than visual estimates. Four different pillars, one underlying workflow, and that's really the point. You don't need 4 different systems to get there. Taken together, these 4 pillars are really one question answered 4 different ways. Is the data telling you something useful, quick enough to act on it? So standing back from both sites, manual processing measured in hours became automated processes measured in minutes. Classification accuracy sat at 90-95% in both cases. Deformation sensitivity held at 25-50 millimeters in both cases. And both operations independently estimated annual value in the same $900,000 to $2 million per site range. Different commodities, different geometries, same underlying pattern, which is exactly what you'd want to see if this is a workflow and not a one-off result. That's the case study. If your operation is capturing scan data on the ground and spending hours turning into useful information, the simplest next step is small. One heading, 1 month of scans, and let the data make the case from there. Thank you for your time, and I'll hand back to Sama.
Great, thank you so much, Matt. I would like to now welcome Bradley Price, Sales Manager at NLT Digital. Bradley, over to you.
Great, thanks, Emma. Yeah, Brad Price here. Sales Manager is my title, but I'm actually responsible for also the development of our intrinsically safe product line as well. So I'll just get into it. So basically, NLT Digital Solutions was created in 2005 in Australia, and we deployed the world's first intrinsically safe Wi-Fi network for coal mines. And with that, then we also added cap lamps, etc., old messenger lamps, and more recently a vigilance cap lamp. Throughout the years, we also won numerous good design awards, both in Australia and the USA, to sort of back up those results. So I'm just going to talk about basically our latest products and where they fitted specifically into some of these issues and challenges with communications and productivity, in particular coal mines, but then how that also transfers into hard rock mining. So, obviously worldwide, coal and hard rock mining operations consistently face challenges related to personnel safety, communications, breakdowns, and inefficient emergency management. These issues significantly impact productivity and operational effectiveness. So a leading coal mine in Australia sought an advanced technological solution to address this challenge and enhance overall operational efficiency. The challenge included improving like a 10-year-old technology that was available for proximity detection and to take advantage of improvements with instant messaging, direct messaging of photos, and integrate into the most widely used proximity detection system in Australia. This new challenge had to work with existing NLT Wi-Fi infrastructure and, of course, that of our competitors and other sources. So NLT Digital proposed a product that could integrate all of these requirements into a single unit. The proposed solution included an advanced cap lamp with ultra-efficient lighting, along with touchscreen messaging, allowing direct messaging and emergency messages to be received and transmitted mine-wide or group-specific from the lamp and unlimited desktop users. It provides tracking of personnel, vehicles, and assets, and it includes useful apps, including a built-in camera, calculator, clock, and timer. It also has a strata proximity module attached on the side that you can see on the bottom left. It fits directly into the lamp base that is user replaceable, removing long servicing delays. It also has a headlamp that is also easily replaced by authorised mine personnel. These key features intended to reduce the downtime experience from faulty proximity detection pads, damaged lamps and cords, and would greatly improve emergency response and productivity. So scenario was that coal mines required a modern cap lamp that included a user replaceable proximity detection module, sound from a built-in speaker, screen indication, and LEDs that indicated into the user's peripheral vision, tracking of personnel, efficient two-way messaging, and reduced downtime for damage caused headpieces or faulty proximity pads. So the solution was we worked with the mine specifically and developed the vigilance lamp with all of these features being built in. A collaboration was also entered into with Strata to jointly develop the pad, and a win-win for end users and manufacturers was realised. Over 3,000 vigilance and nearly 1,000 Strata pads were rolled out across the industry within 18 months of release. The success of this has led to new markets overseas and is being implemented into hard rock mines with the development of a non-IS version that obviously reduces the manufacturing cost and the cost to the end user. This is makes implementation simpler, providing user convenience with improved safety and efficiency for new types of mining other than coal. So as we move from a coal, same type of technology, same tracking, potentially messaging, but use of other devices, iPhones, etc. We then take all of the things that live in the background from that into the non-IS market. And that was specifically a mine that was using a Cisco network, needed to integrate NLT's NConnects and Symphony software suite into the mine's communications and networking infrastructure. This system was chosen for its modular, scalable architecture, ease of installation, user-friendly characteristics, ideal for both technical and non-technical staff to work with change-out service. The proposed solution included tracking, messaging with third-party devices, emergency activation and alarming from the control room, along with deployment of NLT NConnects distribution kits, NLT Wi-Fi access points, reusing where possible existing components, and integrating all systems into a simple, user-friendly, intuitive software package called Symphony. These key features of flexibility reduce the capital outlay required to move the mine into the 21st century, while utilising the investment made in outdated technology where suitable. So the scenario was a modern networking solution that could be integrated with Cisco requirements. The solution needed to be easily deployed, intuitive, and backed up by a reliable, cost-effective on-premises software package. The software had to have local support and not rely on cloud connectivity. Local development also enhanced the integration into the use of existing equipment and NLT-specific tracking tags and wearables. The solution, NLT deployed over 80 distribution kits with almost 900 access points throughout the mine. We provided the mounting hardware, fibre cabling, and Cat6 IP67 cables to integrate into the mine's existing fibre network. Our Symphony software was deployed, providing real-time information on location of personnel, vehicles, and assets. So the result was the NLT was able to work with the customer and engineer the integration necessary, along with utilisation of existing hardware where possible, and add site-specific requirements for reporting, tracking of personnel and equipment locations, emergency evacuation management, along with integration of gas monitoring for display in third-party applications, and it can also be displayed in Symphony if desired. So basically, we provide the network, the hardware, but also in the background, we provide the software that handles all that information that's coming through. So we can pass off OT information for SCADA network that can be gathered, transmitted across the network. But then Symphony also looks after things like NLTV, which is a display TV, which shows where people are within the mine, assets, vehicles, etc. It has the tracking module, which then also displays via a mine map, which is managed through the mine design DWG. It also has all the reporting for start of shift, end of shift, during the shift, locations of where people are at during the shift, a whole host of stuff. We can also do the environmental, which is the gas monitoring, which can be passed off to a third-party app, or it can be displayed in Symphony. We also do emergency management from there. So we can initiate an emergency evacuation from the mine. We can respond to a first aid call, or we can respond to an emergency call from the underground, depending on the modules and the hardware that are used and what the requirement is at the mine. We can also use that tracking data, and we can track vehicles and equipment and people, personnel, assets, whatever. And we have an event composer. And from that, we then use to feed into ventilation on demand. So we're able to increase and decrease ventilation in particular areas of a tunnel or a hard rock mine. The messaging app also integrates with Vigilance and is able to manage those messages back and forth, whether as a group chat or direct messaging or mine-wide broadcast or emergency messages. It's all managed from that. We can also do enterprise or Microsoft Enterprise integration. So if you have Microsoft credentials, etc., you can also log in to the software using those credentials. And of course, the kiosk available that allows transfer either permanently or for a fixed time period of tracking tags, assets. Assets can be assigned to a person and tracked throughout the mine, or we can make sure that they've come back to the surface after being underground. So thanks very much for listening. Thank you, Sema, and I'll hand back over to you.
Great, thank you so much, Brad. Our final presenter today is Ram Rangsamy, Manager, Software Services and Support at MST Global. So over to you, Ram. Thank you.
Thanks, Sema. Hello, everyone, and thanks for joining. My name is Ram. I used to be a product manager in MST. I recently moved into a new role, which is a manager of software services and support. And my focus as we speak is trying to help mining teams turn technology into an operational improvement, a practical operational improvement. So just speaking on today's topic, which is pretty much around how to enhance the workforce performance in underground mining. For me, this is not just like a software or a hardware topic. It's about actually giving crews, supervisors, the operational leaders in the mine, kind of a shared view of what is happening underground, and then using that visibility to make faster, safer, and a more consistent decisions during the shift, not after. And let's get into that. So how does it all work? So the operating model that we have is Helix, which is the operational intelligence layer, what we call it. Kind of tries to bring everything together, similar to what we heard earlier. It brings in people's assets, the actual activities that is done by those assets, the telemetries from those machines on the assets, the mine plan, kind of into a single picture. So the team is not working from sort of different versions of truth. It's from a single platform. The second part is the action part, the cadence, where you not just monitor, you decide, you act, and you verify what's happening. So that's sometimes not the whole story, and it's not like a separate reporting exercise that you have. It's all like sort of a discipline that helps the team that use Helix insights during the shift, while there is some time to recover the actual plan that was during the pre-starts. Just getting into how the whole system works and how we have been helping our customer is the first practical layer we heard about, is knowing where people, assets are at any point in time during the shift. Now, in underground mine, everyone knows it's any simple question takes time to answer, like who is in a work area, which machine is available, what is being delayed, who is already traveling sort of to the next task. So the first step is to actually have real-time people asset tracking, kind of reduces that blind spots. It also enables safer separations, controlled access, and sort of a better handover, and knowing where the handover is happening, and kind of helps with faster dispatch because supervisors can see where people and equipment are and sort of understand what state they are in. So just trying to understand what's happening and where they are is pretty much where we begin with. And then we kind of move into the next layer. So yes, we understand where they are, but you still want to understand what an asset is actually doing, right? At a particular point in time, at a particular location. So a dot in the map, as in a person or a vehicle in the map, tells you something, but it doesn't tell us whether it's a work that is actually moving. So Helix kind of becomes more valuable where kind of location is linked to the task and sort of the expected sequence. And you kind of add telemetry on top of it. For example, if a specific task hasn't moved forward, was it a breakdown? And sort of telemetry kind of comes into the picture to provide a proof to those information. So, and kind of all brings together. So what it essentially does is kind of allows the team to distinguish between what is an operating time from like a waiting, a travel, standby, delays, or downtimes, and tries to understand where kind of the hidden loss sort of becomes visible during the shift again. If a crew is in the right place but cannot start because there is access issues or services or the previous task was not completed, the readiness is missing, the supervisors can quickly reassign, escalate, or recover that shift. And so just moving into the next one, I think this is where we kind of bring everything together. As I mentioned earlier, Helix kind of brings that shared truth. People still sort of need to have a disciplined way to act on it. And so a short, frequent, sort of an exception-led reviews help the team focus on those decisions that matters inside the shift. They can compare planned versus actual, identify the constraints blocking the next sort of a productive step, reprioritize people, equipment, kind of escalate blockers. If an existing crew is affected, kind of redeploy them, and then verify that that action is worked. I think this kind of sort of keeps the conversation practical. It's not like it's not like a separate reporting exercise that you need to do outside the system. It is a way to use those kind of live information to protect the plan and kind of recover faster when condition changes. And what does telemetry brings into this picture is the truth, the evidence of sort of the operating picture. For example, if a mobile equipment is down, you kind of quickly understand what's happening with those machines, and you are able to react quickly for production down. If another classic example, I think I'll probably touch on that a bit later, is the environmental information that will help to determine why the crews can't go underground after a blast because the gas is still high, for example. And kind of this matters because location alone rarely explains like what is the cause of the slowdown. A mission may be present in that location because we know where it is, but the reason for waiting could be like, as I said, like different issues that could cause that, the access services, and the state of the equipment as well. So kind of you combine the telemetry, not just on the machines, but sort of using fixed sensors, monitoring sensors, and then kind of bring that together with people tracking, vehicle, the activities that we talked about, and understand where work is actually happening and where and why the work is not progressing. And so kind of gives you an overview picture on how the system actually works. And now, in terms of where the use case has been, some of the examples, as you can see. So when you have a blast, I think normally the way that it works today is, or not, some of the mines where you have a blast happens, people take the sensors going underground. After 30 minutes, 40 minutes, there is no sort of a fixed time, measure the gases, and then the crew starts coming down. So once you start to have those kind of fixed sensors, not necessarily at the blast phase, but somewhere in a return airways, for example, where you will be able to measure the gases and be able to quickly send the crew downstairs to the mine. And the value is simply not having more data collected. It's about removing the avoidable waiting times and sort of improving the confidence in the operational decisions as well. And I think there was an earlier mention about the ventilation system, a classic one at that, trying to understand why you need to turn it on a ventilation and when you can turn it off as well. And the kind of the same pattern sort of gets applied to the readiness and the maintenance response and sort of the handover quality as well during the shift. In each case, kind of Helix helps the team detect the issues earlier, validate the condition sort of faster, and sort of release works with more confidence. So, and just getting into the value of what Helix brings in, it's kind of role-based, right? So you have different people trying to do different things during the shift. You got the same sort of an operating picture, but supporting different people in different roles. A crew member kind of needs a clear next instruction. That's it. The access status, what has changed since the pre-start. It could have. A supervisor needs to know the constraints, the available people, and the equipment and the recovery options that are available for him or her. The control room needs sort of an exceptions on the coordinations around the visibility of it. And so the planning needs like an actual work states, delays, and the constraints to improve the next plan and the handover. And kind of this one shared platform reduces those kind of like a duplicated administration works. Each role kind of receives the context on what they need to do next, again, sort of during the shift. So, and that's pretty much our focus has been, trying to reduce the number of systems that a mine has to be able to deliver or solve multiple problems. And finally, I think for us, the target state of an operation is sort of having a visible, contextual, and sort of an actionable insights, kind of what summarizing visible means, like people, equipment, and work areas, sort of no longer hidden during the shift. The contextual means like the location is connected to a task, sort of a telemetry, and sort of a planned variance. And so to us, that's how workforce improvements happens. You kind of have a safer workforce, you know where they are, what they're doing. You kind of have a less waiting, knowing that it's not actually going to the plan or going to the plan with a quicker information during the shift, clear priorities, and sort of, most importantly, better asset utilization and sort of adhering to the plan in a strong sense. And just to close it off, I think Helix connects all these informations, the operating cadence coordinates the decisions, and the people are better supported to deliver the shift, actually. So thank you. Thanks, Emma.
Great, thank you so much, Ram. Great to see these four different perspectives to this challenge. So we'd like to now move on to our Q&A. It's great to see that we've had a lot of questions come through the Q&A box already. If you haven't already submitted a question, you can use the Q&A button at the bottom of your screen. So I'll just move on to the first question from Charles. This is for Matt. Charles is asking, how did the operational people underground adapt to the quicker information flow for their work, and how did the people doing the manual process respond to the change?
Thanks, Charles. Yeah, that's a great question. To be clear, what the change is, this isn't about removing the survey team. It's about changing what they spend their time on. So the manual, repetitive part of the job, things like dimensioning a roadway by hand or comparing scan-to-scan measurements one at a time, that's what got automated. Previously, that was 4 to 6 hours per data set. So one specialist working through one data set at a time. So what that freed up was the surveys team time to focus on exceptions, validation, and the judgment calls that still need a person. So rather than spending most of the day on routine processing, they're spending it on parts of the job that actually need their expertise. So on the operational side, the shift was really about speed of access. Instead of operations, safety, and engineering teams waiting days or weeks for the results to come back from the survey department, they're getting that information far more quickly. So the adaptation for them was less about learning something new and more about getting used to having answers on hand when they needed them rather than waiting for them. Thanks, Emma.
Great, thank you. And next up, we've got a question for Courtney. The question is, this research was conducted in the Australian agriculture. So why do you think the findings are equally relevant to the mining industry?
Yeah, it's a good question, and I think important to make the distinction. So I don't think the value lies in exactly what the drivers are, and nor would I say that the drivers for a mining industry would be the same. I think they're very clearly different, and your challenges are different. But I do think that between the industries, there's a lot of shared challenges. For example, regional operations, competition for skilled labour, the utility and mobility of workforce, and probably attracting to regional communities of interest as well. So what I would urge you to do is think about the transferability of the methodology itself and some of those key insights. I'd also note that trust was actually moderating a lot of these discussions. And when you look at trust itself between the mining industry and Australia, there's many similarities, in particular, including the environmental piece and that procedural fairness piece. So there are some insights that you could take away and reflect on and see how they may, relate to your particular industry or workplace of interest.
Great. And Courtney, just another question just off the back of that. So how do you capture the information on motivation for applying for a job and then monitoring the ongoing satisfaction factors for the staff?
Yeah, so this particular research was conducted with a multifaceted approach. So we used panel data. So we went out and got a panel company to collect survey responses in the first instance. We also did open call. So we went out to companies and gave them a special link, and they used that link to distribute out to both their workers and their general community. And we also conducted caddy interviews, so calling people, and did some research in the field for uber regional areas where you couldn't really understand what the community was thinking unless you were specifically on the ground talking to people. So that's how we collect the baseline consideration data, as well as some of the information on retention, because people were probably more likely to talk about experiences in the workplace if the workplace wasn't initiating that conversation themselves. How you could do it ongoing is effectively just running that survey year in, year out. You can have repeat participants run that methodology again, or you could work through an industry body, which is something that we've done, and they send those links out year in, year out now.
Great, thanks, Courtney. The next question is for Brad. So the question is, as I understand, there is a number of systems already in place around our coal mine. So wondering how the strata integration is different and better than existing deployments.
Yeah, so I think I'll just clarify there a couple of things. So the first, there's strata, there's matrix, PBEs entering the market. There's then in the non-IS market, there are similar sorts of players, including Becker, add to that. And then there's lots of different visual AI camera-based devices as well. But with specifically the coal mining industry, the thing that makes this product different is utilizing the strata system, is that because we have a microprocessor base with the lamp, we can now tailor all of the messaging. It's a lot smarter, it's a lot quicker. We can then integrate that with other companies. So we're totally agnostic with who we operate with or who we would develop with. And essentially the infrastructure is there within the current lamp design. And then the same flexibility can now be transferred to other manufacturers. And that is typically now, if you wanted to repair the lamp, you would have to ship the complete lamp and the proximity device together. If there was an issue with the proximity, you had to ship the proximity with the lamp together. At the moment, so now what I've been able to do here is revolutionize that whole thinking. Now, if there's any fault finding required, authorized person can remove that pod, put a new one on, place it in the charger, reset the unit, test it, and if they find that everything is still operating fine, they can just send the individual pod away. They don't have to send the whole cap lamp. Just makes things a lot easier, a lot quicker, a lot simpler. So it's the same technology, just improved and greater flexibility.
Great, thank you. Our next question is for Ram. The question is, a lot of operations are dealing with information overload. How does your system help supervisors focus on what matters and avoid this becoming a more data, more noise situation?
Thanks for that. I think one of the recent trends is trying to have more dashboards on trying to provide information to a supervisor who during his shift doesn't want to look at everything that's happening. He just wants to have an information where there is an exception. And so what our system tries to do is some of the examples are if a person or an asset is in a part of a mine that they are not supposed to be, raise an exception. If there is mission alarms and asset alarms that gets triggered, raise. So we kind of try to create an exception status and be able to provide that information to the supervisors or the control room, more than looking at an operational data, which kind of is where we want to get towards, more than just trying to dump all the data, and nobody's going to be looking into 2 pages of dashboards that's going to provide normal status of an operational mine. So, and so we are gearing, we make sure we fine tune the system and we set it up, trying to make sure that those kind of exception is what is being used by the control room, by the supervisors, and for the operational leaders, it's normally end of a shift reports or a weekly reports. But keeping that aside, if the shift happens, you want to have exceptions happening more than like providing raw data and standard dashboards.
Great, thank you. And our next question, Matt, does Pointera's technology replace the survey team, or is it more about changing the way they work?
It changes the work rather than removing the team. So the manual repetitive parts of the processing, like dimension roadways and comparing scan-to-scan measurements by hand, are automated. So that frees up the survey team to focus on the things that they can do better themselves. So they all still need other things, need that person. So rather than spending that 4 to 6 hours per data set on that routine processing, it's removing that component.
Great, thank you. And I think we've just got time for one more question. So I've got a question actually for Courtney. If there was one lesson or insight from your research that mining organizations could apply tomorrow, what would that be?
So I think it's about the fact that attraction and retention are completely different problems, and without an understanding of what those problems are through data-informed strategy, we're really wasting our time and we're not giving people the experience in the workforce that we hope we are giving them. And so I would urge you to think about how you can diagnose and prioritize workforce issues in the most efficient way for your industry.
Great, thank you very much. That's all we have time for in terms of the questions. So big thank you to all of our presenters. If we didn't get to your question or you have any questions you would like to present to any of our presenters today, please get in touch with the Austmine team and we'll be happy to connect you with the relevant presenter from the webinar. So once again, a big thank you to all of our presenters today. It was great to see the different perspectives and a great Q&A session just there. Before we wrap up, I would just like to let you know about the next webinar in our series. It is Removing Bottlenecks, Unlocking Throughput Through by Targeting System Constraints. So this webinar will be held on Monday, the 15th of September, and we'll explore how METS companies are helping mine sites identify operational constraints and improve throughput through engineering expertise. So to register for this webinar or any others in the series, just simply visit our website. And the recording of today's webinar will be made available on demand and shared with all of you post this session. So we look forward to welcoming you all to another webinar soon. Enjoy the rest of your day and thanks again.
Thank you.
Thank you.